Okay, here we go again. Welcome to the chapter 3.1 to 3.4a quest review. It says 3.4a because we're not on this quest. Everything from section 3.4 isn't going to be covered. Number 1. Write the ordered pair of coordinates of the 2 points already on the graph. That's this one and this one. Then plot the following ordered pairs. -2, 6, 3, 7, -5. That should be a -5, -2. Let me fix that. Then it says to state which quadrant each point is in, or if not in a quadrant, which axis it is on. Okay, so we'll start with this one first. Count from the origin back 1, 2, 3, 4, 5, 6. Okay, so that's -6, and then it's 0 on the y, you know? 0 on the y is right here. So -6, 0. The x component goes first, the x coordinate. I have to write it here because I'll never fit it in that spot above. Okay, -6, 0. Next one is this one here. Count from the origin 1, 2, 3, and then, so that's 3, and then down 1, 2, 3, 4. So 3, -4. 3, -4. Okay, now we have to plot these other ones. -2, 6. Back 2, up 6. Right to there. It's hard to get these dots to be very tiny. Okay, so -2, 6, and then there's 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, right there. And then -5, -2. Back 5, 1, 2, 3, 4, 5, and then down 2, 1, 2. Okay, now we have to identify the quadrants. So the quadrant that's positive, which is this one here, is quadrant 1. Then you just count counterclockwise from there. So this is quadrant 2, quadrant 3, quadrant 4. So our first point that we were talking about here is this -6, 0. Well, that's not in any of the quadrants because it's right on the axis. So we have to say what axis. It's on the x-axis. X-axis. That's supposed to say x-axis. Okay, the next one, 3, -4, you can see is in 4. Okay, -2, 6. That's this one right here. You can see it's quadrant 2. 3, 7 is quadrant 1, and -5, -2 is quadrant 3. Okay, number 2, give the coordinates of the origin as an ordered pair. The origin, that center point here, you notice it's 0 for x, right in the center, it's 0 for y. 0, 0. Number 3, determine whether the ordered pairs are solutions for the given equation. Now remember, an ordered pair is like the first coordinate is the x coordinate, because x comes first in the alphabet, remember, and the second is the y coordinate. Okay, so the first is the x value, the second is the y value. So of course that's what we substitute into these equations. We substitute the x value in for x and the y value in for y. So the first one, in this equation of 7x minus 1/2 y equals 11, the first one we're going to check out is this one, 2, 6. 2 is the x value, 6 is the y value. So that's what we stick in. We'll stick in the 2 for x, and all you do is substitute. This is just a substitution type thing. So we've got 7 times 2, our x, minus 1/2 6, which is our y. And that has to equal 11. So both sides have got to equal 11 when we're done here. Okay, so 2 times 7 is 14. 1/2 times 6, negative, or minus 1/2 times 6 is minus 3. Or a negative 1/2 times 6 is a negative 3. Works either way. Okay, 14 minus 3 is 11. So that one works. Let's do the next one. Okay, we'll stick in the 1 for x. 7 times 1 minus 1/2 times a negative 8 equals 11. Let's see if this is true. 7 times 1 is 7. A negative 1/2 times a negative 8 is going to be positive. 1/2 times 8 is 4. So it'll be plus 4. And yes, that equals 11. So that's good. Let's try the next one. We have 7x minus 1/2 y equals 11. We'll substitute the 3 in for x, right? Because the 3 is the first one. It's our x coordinate. We'll substitute in the 10 for y. And this has got to equal 11. Okay, 7 times 3 is 21. Negative 1/2 times positive 10 is a negative 5, or minus 5. Does that equal 11? Well, 21 minus 5 is actually 16. 16 does not equal 11, so that pair is a no. This one's a yes, this one's a yes, but 310 doesn't work, so it's not on the line. It's a coordinate pair, but it's not on the line. Number 4, use the graph to answer the following. The graph represents the percent P of high school graduates that go on to college during year X. Okay, so now P is our Y. See, it's on the Y, the percentage is over here. See, it says percentage, it's on our Y-axis. So that P is our Y, and then the X, that's our year. Okay, so first question is, and this is just about reading these graphs. You know, how do you read a graph? Okay, so what is the approximate percentage of high school graduates that went on to college in 1980? Okay, we find 1980 right here, and we go straight up to the line. Okay, that's where the line is. Okay, now we have to go straight across to the percentages, or our Y. Go straight across, we get to here. It's about 45. So that answer is 45%. The next one, in what year did approximately 65% of the students go to college? Again, we're reading the graph. Go up, where is 65? Well, it must be halfway between 60 and 70. All right, from the Y then, to find our X, we go straight over to the line. And, I'm having a hard time reading this. I think using a ruler here would help. I think it's this one. It's close to 65%, so we're going to use this one. So if you use I just went, while I turned it off, I used a ruler, and it goes right to this spot here. So that's it. So that's our point on the graph. Now to find out what is on the x-axis, you just go straight down. Well, it's the year 2000. That's 65% of the students went on to college. So we'll put that in, 2000. here, this is why it says approximately, see, because we're reading a graph is not going to be an exact thing. You're not going to find exactly the right answer. You'd have to use an equation to find the exact answer. Okay, the last one, C. What is the approximate difference of the percentages of high school graduates that went on to college between 2010 and 1980? All right, well, the difference is a subtraction. Let's find out what it is in 2010. 2010. Straight up. Okay, and then I'm using a ruler, you can't see it, but it looks like 75. Okay, so that's 75%. Okay, and that's going to be minus there it is. Okay, minus the one in 1980. So again, we already figured out 1980s, which was 45%, but I'll just go and show it again. It's right there, 45%. Okay, so minus 45%. 75% minus 45% is 30%. So that's our answer, 30%. See, this is just all about reading a graph. That's all there is to it. Number 5. Okay, during the month of January, the depth y of snow in inches at the base of one ski resort could be approximated by this equation. Y equals a negative 2x plus 60, where x is the number of days since December 31st. So we're talking about January and the number of days after December 31st. Okay. A. Complete the table by hand or using your graphing calculator. Alright, so we're going to start out completing it by hand, and then we'll try it with the graphing calculator. Now there's some tricks to doing it by hand, and graphing calculator is always easy to do it. I mean, once you figure it out, it's very easy to whip up a table of values. Okay, so we have our equation that is y equals negative 2x plus 60. Okay, so what about when x is 0? So we just plug in, each of these x's for x, and then we'll determine what the y's are by doing so. Okay, so we've got y equals negative 2, the first one is 0, so times 0 plus 60. Okay. Negative 2 times 0 is 0, so we have y equals 60. That's our first one, 60. Okay, let's try the next one. Well, equals negative 2 times, no, 5 is our next one to try. Okay, so negative 2 times 5 is a negative 10, plus 60. Negative 10 plus 60 is 50. That's our next one. Now while we're doing these, excuse me, notice that the x's go up by 5 each time. You know, 5, 5, 5, 5, 5, you know, 5, 10, 15, 20, 25. Okay, so there's a pattern right there. So we're going to watch for a pattern to show up in our y's. Okay, y equals, our next one is 10. Negative 2 times 10. Just see, just plug it in. Negative 2 times 10 is a negative 20. Plus 60 is 40. Okay, so you see the pattern here now? In the y's, the difference is 10. 10 each time. Since we have a regular pattern up on top, and we have a regular pattern on the bottom, we can just extend this pattern, this bottom pattern here. So 60, 50, 40, so 15 would be 30, 20 would be 20, 25 would be 10. And let's see, if we extended it one more to 30, then that would be 0. 30 would be 0. Subtract 10 each time, see? 60 minus 10 is 50, minus 10 is 40, minus 10 is 30, all the way down to 0. Okay, and the difference is 10 all the way along. So now notice something. the difference in our x, going in the same direction, you know, as we're going from left to right here, we add 5 on the top, add 5, add 5, add 5, add 5, add 5, add 5. At the bottom, we subtract 10, subtract 10, subtract 10, subtract 10, subtract 10, subtract 10. So, actually, we want to put negative. So negative 10 is our y, our difference in our y's. And I don't know if you remember what that is. The difference in our x's and the difference in our y's. The difference in our y's is a negative 10. The difference in our x's is 5. I just want you to notice this. So that means our slope. This is a slope. Our slope is a negative 2. Or you could take these as points. Each one of these is a coordinate pair, right? So the first one, the x is 0, 60, and the next one is 5, 50, and then we've got 10, 40. If we do our slope equation, m equals y2 minus y1 over x2 minus x1, and we pick 2 of these. Let's say, let's make this one this one here, we'll make that our number 2. We can make this one our number 1. It doesn't matter which ones we pick, remember. Okay, so if this is number 2, this is x2, excuse me, x2, y2. Here we have x1, y1. So our y's, the y2 is 40 minus 60, or y1, and that's over the x2, which is 10, minus x1, which is 0. So 40 minus 60 is a negative 20. 10 minus 0 is 10. Notice, negative 2. I just threw that in. We don't need that to solve this problem, but it's good to know that. Okay, so we completed the table by hand. Now we've got to do it with the calculator. Okay, so if we're going to work with the calculator, best thing to do, and we're going to work with tables, and you notice that, you know, on our handmade table, well, even before, if we didn't have any of the values on there except that we had the x values, you notice they go up by 5, 0, 5, 10, 15, 20. And when we do the tables, we can either put in x values or to give x values, and then it'll show the y values for it. See, so we can tell the table where to start, and then how far it should jump between numbers. Like, so for instance, if I said start at 1 and jump 10, it would go 1, 11, 21, which wouldn't do us any good here. So you'd think, well, what would do us the most good here? And that would be to have it start at 0, because that's where this thing starts, and then have it go up by 5 each time. Then it'll give us the exact values we want. See, because it'll give this table start for x, and then the difference will be in x, and then that will produce the y's. X always makes the y's for the most part. I mean, sometimes we'll go from y, we'll find our x from the y, but most often we're starting with the x. So let's do that. Look at the table set. To go to the table set, you can push second button and then push this button. The blue color is on table set, and that'll get us to this page. And notice it says table start. So that's where you'd want to put 0 in. You're going to put a 0 in here, and then you go down arrow, and here this triangle means the change in the table. So in here we put 5, and that'll get us all set up. And then down here we want it just to be on auto. So you go left arrow, you get down here, down arrow, and you get to this, it'll be on ask, and then push left and it'll go to auto. And then you want this one on auto also. Next place we go is we go to this y equals. Don't push the blue button this time. Just go to y equals. You get to this page. Of course, you're not going to put in this equation. That was from something else we did, and I don't feel like making another picture, frankly. So instead we're going to put our equation in, this one. Y equals negative 2x plus 60 using your keys. You're going to put it in this first one here. And if you have something in there, you can just push clear. You have the cursor here, push clear, and that will disappear. And then you just put in negative, use the negative sign. It would be like negative 2, and then push the x, and then plus 60. Put that in there. Then after you've done that, you go to second, and then table. And then it will give you the values for our equation, negative 2x plus 60. Notice that this equation also is already in terms of y. You can't put anything into this unless it's in terms of y, in y equals form. So this is the table you'll get. Notice it starts at 0 and it goes up by 5, 10, 15, 20, 25, 30. And it gives us our values for y, which is a pretty easy way to get those values. Okay, now that we've got our table, we can graph the line using the appropriate scales. Now, what the heck do they mean by appropriate scales? Well, first of all, we have to decide what's on the x and what's on the y, right? So this is our x, this is our y. Okay, so what is the y? Okay, see, during the month of January, you notice up here, during the month of January, the depth y of snow in inches at the base of one ski resort could be approximated by that. Okay, so it's the depth y in snow, inches in snow. Okay, so let's put that in. Snow inches. Alright, I don't like that. Let me try something else. How about this? Inches of snow. Alright, so now what should our numbers be? I think obviously we've got to start at 0. We look at our y. Look at our y. It goes from 0 to 60. Okay, so we've got to have at least from 0 to 60. So let's count how many of these things we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, 12 and 6. See, 10, if you go 10 every time, it'd be by 6. So we could go 20. We could do this. This is what I mean. 10, 20, 30. So let's do that. All right, well, it goes 0. This is 0. 0. 10, 20, 30, 40, and these are inches of snow. 50, 60. That works out quite well, even though it may be hard to read. Okay, now our x goes from 0 to 30, so count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we can divide it up by 10, 3 into 12 is 4. We can go 4 every time if we want to spread it. You don't want to make your kind of graph as big as possible so you see more detail. Okay, so we can skip 4. 1, 2, 3, 4. So that would be 10. And then 1, 2, 3, 4, 20. Oops, I skipped 1, 2, 3. Oh, I did that wrong. All right. Okay, everything's trial and error, right? $10, $20, $30. Okay, and then what is this? What is x? Well, where x is the number of days since December 31st. Okay, so this is days since 12/31. For instance, this is 10 days or the January 10th. This is 20 days. That would be 15. Okay, so, alright, so now we have to put our data in. Graph the line using the proximate scale. So 0, 60, our first point. 0, 60 would be way up here. 0, 60, and then there's 550. This is 5. Whoops. I always get what I want. Alright, that's 5. 550 would be right here. Okay, and then we've got 1040. You see where I'm getting these numbers, right? 0, 60, 550, 1040. We don't have to actually graph them all. We can, though. I might just do that, but we don't have to. So we have 560, or 1040 is right here. 1530 is right here. 2020 right there. 2510. Notice that all the points are right on the line. And then the last one is 30. Okay. And so that's where our line is. Alright, I'm going to try to graph on this iPad, or draw a line on this iPad. Not an easy thing to do, but I'll try. Nothing's happening. I have to do it by hand. I can't get the ruler in there. Okay, anyway, you can see what we've got going on there. Remember, you can figure out your slope from this. Notice that the slope is a negative slope. Negative slope. I think we figured out our slope to be -2. Right. Yeah, -10/5 is -2. So our slope's a -2. Now the negative, that kind of indicates it's going down. If we wanted to write this as in terms of a change of rate, it's inches of snow per day, and the inches of snow per day, inches per day, is going down. So by the 30th there is no snow left, which doesn't make a lot of sense really. It's a ski lift in January, at least not this year anyway. There are some years when we didn't have much snow. Alright, C. Estimate the depth of snow on January 15th. Okay, so we have to find January 15th. There's 10. We skip 2 for every 5. See, you notice? 5, 10, 15, 20. So there's 15. What is it in the 15th? It's 30. And we could have read that from our chart for that matter. X. So 30. That's the depth of our snow. Alright, there we have it. Number 6. The graph depicts the amount of water left in the bathtub. Alright, so when you see a graph, you don't have to automatically somehow know everything that the graph is doing. But you want practice. The more practice you get at it, the easier it is. And graphs aren't necessary. You shouldn't be scared of them. Just give yourself some time to understand what's going on. On this graph, notice it says water in gallons are on this side. So water in gallons. So we got 10 gallons, 20 gallons, 30 gallons, 40 gallons, 50, 60. Alright? And this our graph is touching the 30. So 30 gallons. And then down here, this is time in minutes. So we have 1 minute, 2 minute, 3 minute, 4 minute, 5 minutes, 6 minutes. Start out with that. And then let's look at this thing. Okay. Okay, the graph goes from 30 here in the gallons all the way down to 3 in the minutes. But that's actually not how we read the graph, right? The 30 is at 0 minutes, right? This is 0. And when it's 3 minutes, this is when it meets this line here. 3 minutes it's 0 in the gallons. So the gallons are 0 here, and the minutes are 0 here. Okay, so now we've got that figured out. So now we'll just look at the questions. And by the way, all right, the graph depicts the amount of water left in a bathtub. Left in a bathtub. Okay, so at 0 minutes, there's 30 gallons left. At 3 minutes, how many gallons are left? 0 gallons, right? Because you read it from the y. Put in the x, the 3, you get 0 on the y. That tells us how many gallons. This tells us the minutes. This tells us the gallons. Okay, so x-intercept, that's where our thing crosses the x-axis. So that's at 3. And we can just write 3 there. If we wanted to put the ordered pair, well, it's 3, 0. 3 is the x value, 0 is the y. Same thing with the y-intercept. The y-intercept is right here. That's where it crosses the y, right? There's the y. Crosses the y right here at 30. So we could just put 30. 30. Or if we were writing the points, it would be 0 is the x, 30 is the y. Okay, so now let's look at the next question. Which intercept represents the emptied bathtub? Okay, well, emptied bathtub would be 0 gallons, right? So when is it 0? Empty bathtub, and it tells us it's the intercept. It'll be at the intercept. So it's not empty here at this intercept, but it is empty here. So which intercept represents the emptied bathtub? That's the x-intercept. Okay, so now find the slope. What is the rate of change? Find the slope. Well, we've got 2 points here, you know. We've got this one, and we could find more points, but these we know definitely, right? We've got 3, 0, and 0, 30. Well, let's say, all right, let's call this one number 1. It doesn't matter, and this one number 2. Okay, so if that's the case, then this is x1, y1, and this is x2, y2. Okay, m equals y2 minus y1 over x2 minus x1. And slope, what is slope? Slope is the slant of this thing. And remember, we read the slope from left to right. So the slant going down, see, it's going down from left to right, so it's a negative slope. And we'll see that it's going to turn out to be negative when we do the numbers here. So our y2, this is negative, okay, or minus, y2 is 30, and that's minus whatever y1 is. Y1 is 0, okay, and that's divided by x2, which is 0, minus x1, which is 3. Okay, so put it down here. 30 minus 0 is 30. Okay, 0 minus 3 is a negative 3. Okay, if we divide 30 by a negative 3, we get a negative 10. Okay, so remember I said our slope was going to be negative, right? Because of the slant of this thing. It's slanting, it's going down from left to right, so it's going to be negative. And now we've figured out the actual number of it. It's a negative 10. And we could have written it as a negative 10 over 1. So this is our rise. Well, it's not rising, is it? It's falling. But our rise is a negative 10. It's negative 10 going down. Okay, and this is our run. So for every 10 it goes down, it runs 1 minute. Right? So now, so that was find the slope. We found the slope. What is the rate of change? All right, to find the rate of change, remember we're doing, this is rise over run. It's change in y over, remember we talked about the triangle being change, and over the change in the x. Well, what is y? Y is gallons of water, right? The change in the gallons of water over the change in the time in minutes. Time in minutes. Okay, so change in time in minutes. So it's gallons per minute. and the slope is a negative 10 gallons per minute. So that's the rate of change. If we wanted to find out how many gallons were left at 2 minutes, well, we could just go up in our chart, go up to this point right here, and then look across. At 2 minutes, there'd be 10 gallons left. Actually, if you're clever, you could actually figure out the formula for this. All right, good. All right. Number 7 and number 8 are to find the x and y intercepts for the equation. Now, do we have to graph it to find this? Well, no, but it helps to see a graph. So I'll just draw one in. Okay, so this is our y and this is our x. The x-intercept is where it crosses the what? The x. The y-intercept is where it crosses the y. Okay, so it says to find both of them. But you notice where it's going to cross the y, it's where it's 0 on x. So everywhere along here, it's 0 for x. And then the y-intercept, or the y-intercept is the 0 for x. Did I just say the opposite? The y-intercept is the 0 for where x is 0. The x-intercept is where y is 0. But the x-intercept is where it crosses the x, and the y-intercept is crossing the y. So you can think of an interception, you know. That's where it's going to intercept the y-axis, or intercept the x-axis. Alright, so if I haven't totally confused you, let's figure it out from these equations. So we have 2x plus y equals a negative 8. 2x plus y equals a negative 8. Alright, so if I'm looking for my x-intercept, where it's going to cross the x, that's where the y is 0, right? So let's stick in a 0 for y. So we have 2x plus 0 equals a negative 8. Alright, or 2x equals a negative 8. Divide by 2, we get x equals negative 4. Okay, so we'll write our x-intercept in up here. That's negative 4, where y is 0. X-intercept. Okay. You can read that, and I'm going to put the y-intercept over here. Okay, so that was the x-intercept. That's what the value of x where y is 0, right? All right, so now let's find the y-intercept. We go whoops, didn't mean to do that. It is, this isn't working. Okay, y-intercept is where x is 0. 2 times 0. Sometimes this thing doesn't work the way exactly I'm expecting it to. Okay, so 2 times 0 is 0, so we have y equals a negative 8. So the ordered pair here would be x is 0 this time, and the y is negative 8. That's all you have to do. You don't have to graph it or anything. There you have them. It's a handy thing to do, to graph though. Okay, let's do the same thing with the next equation. We've got y equals 1/2 x plus 2. Okay, so let's find our x-intercept. So x-intercept, right, is when what is 0? Y is 0. 0 equals 1/2 x plus 2. Okay, so now we want to get our x alone, right? So we add a negative 2 to both sides. This one becomes 0. We have 1/2 x plus 0 equals a negative 2, which is a negative 2 equals 1/2 x. Now we want to get the x alone. We just want positive x equals something. So to do that, we've got to multiply that 1/2 times its reciprocal, which is 2. So we'll multiply 2 times both sides. 2 times 1/2 x, and I don't know if I can get it in there, 2 times a negative 2. So 2 times a negative 2 is a negative 4. 2 times 1/2 is 1. So we just have x. X equals a negative 4. So the x-intercept for this is negative 4, where y is 0. Alright, so now let's find out what the y-intercept is. Again, same equation, y equals 1/2 x plus 2. Okay, the y-intercept is where the x is 0, so we'll have y equals 1/2 times 0 plus 2. 1/2 times 0 is 0, so y equals 2. So this coordinate is 0, 2. Not too hard. Okay, write an equation for the graph below. Now look at that graph. It's a horizontal line, right? When you have a horizontal line, you know, wherever it is, here or up here, or if you have a vertical line, one of the values, either the x or the y, is going to be the same all the time. You just have to figure out which of the values is the same all the time, and that's what it equals. So, for instance, is x the same all the time here? No. X can be different. X can be anything along here. X can be anything. But what about y? Y is the same all the time. There's only one thing y can be for the equation that this is going to be. Y has to be a negative 2. So this is 10. We have to count it down. We see there's 10 of them in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this must be y equals negative 2. Y equals negative 2. No matter what x is. So like we could make an equation with two variables here. We could say, okay, this is 0x plus y equals negative 2. And so y is going to always be negative 2 no matter what x is, because x is going to be multiplied by 0. So we would just write it this way.